Okay, so law of sines is the first of two methods that we're going to use to solve triangles that are not right triangles. If they were right triangles, we used SOHCAHTOA, right? We use sine, cosine, tangent. But we can't use that on things that are called oblique triangles, which are not right triangles. We use two options. One is law of sines and one is law of cosines. And based on what information I give you, that's how you determine which one you're going to use. So there's 6 parts to a triangle. We're going to find all 3 angles and all 3 sides. And depending on if I give you like all 3 sides or 2 sides and an angle, that determines whether you're using law of sines or law of cosines. Sometimes you can flip and flop between the two, but starting out, there's only one option, okay, which you'll see. So law of sines is the most basic equation. It's the easy part, which is the angle, the sine of the angle over the actual side that matches it, or vice versa, is in a ratio format. So if I'm given side A, I would put side A over the sine of angle A, and I could set it equal to side B over the sine of angle B, or I could set it equal to side C over the sine of angle C. It doesn't matter if the sides are in the top or the bottom, so notice down here you can flip that as long as you're consistent. So if you put the angles in the top, it's fine. If you put the angles in the bottom, it's fine. You just have to be consistent with all the different ratios. And we would do 2 of these 3. You will be given 3 of those 4 pieces of information. You'll cross multiply and you'll divide. So if you can find the sign button on your calculator and you can cross multiply and divide, you can do law of sines. The catch to law of sines is that there's like an ambiguous case, which is a pain in the butt, which we'll get to, and you'll know it when we get there. But the simple part is the equations, and then the actual calculator does most of the work for you. You just got to be careful with your mode and that kind of stuff. So this is where it's derived. I will never test you on this, but if you're sitting at home and wondering like, oh, I wonder how law of sines came to be, this is how it came to be. Okay, I'm not teaching you this. I'm not going to make you learn it. But this is how it came to be. If you actually took a right triangle or an oblique triangle and you cut it with its altitude, which is going to make it into 2 right triangles, you could find the side lengths based on SOHCAHTOA, and then that's what the H is. The H would be the altitude. And then you could use 2 of those at the same time and then set them both equal to H and then use substitution. And that's where these ratios come from. Again, I'm not going to test you on this. Just know that it's not some made-up formula that doesn't work. It will always work. So an oblique triangle, which is what I mentioned already, is a triangle that does not contain a right angle. So this is what you're going to use for... I don't want to lose them completely. No, it's just going to get cut off. I have to have this view on because I need to use my calculator. Oh, not that one. On the video. Hello. So try to ignore the tools for a little bit because I have to use, those are going to have to be there I have to use this view in order for you to be able to see my calculator. All right, sorry. Oblique triangles are triangles that don't contain a right triangle. So we won't use the Pythagorean theorem to solve these. It wouldn't work, okay? If we have a right triangle, we'll use the Pythagorean theorem. If we do not, we'll, again, choose between law of sines and law of cosine. So this example literally says solve the triangle, and when you see the word solve the triangle, it means find all the missing angles and all the missing sides. So based on what you're looking at already, I've got angle C, I've got angle A, and I've got side C. What I'm missing is angle B, I'm missing side A, and I'm missing side B. Capital letters are used to name the angles, lowercase letters are used to name the sides. So what I want to do is figure out, if I'm using law of sines, I need one full complete ratio. So which of the letters do you have both the angle and the side for? C. C, good. So I'm going to use C as the one to always set things equal to, okay? So I'm going to say small c, which is the side, over the sine of angle C equals. Now the other one I have part of the information on is angle A. So I can say side A over the sine of angle A. So I have 3 of these 4 pieces of information. Side C is 32. Sine of angle C is 43 equals A is what I'm missing over the sine of angle A, which is 20. Now all of these angles are in what measurement? Radians or degrees?
Degrees.
Degrees, which means your calculator has to be in degrees. So from here, I'm going to take this ratio, I'm going to cross multiply A times the sine of 43 equals 32 times the sine of 20. And then the last step to solving this would be to divide both sides by the sine of 43. So I'm going to type this whole thing in my calculator. 32 times the sine of 20, close the parentheses, divided by sine of 43. Almost all of these will tell you to round to 2 decimal places, so that's what we'll do. So that's A, side A, 16.05. Do not round before you need to. So don't type this one in my calculator, round it, and then divide it by the sine of 43. Every time you round, it gets less and less accurate. So you don't want to round it. You want to save it all the way to the end and then type that in the calculator. Okay, I'm missing angle B. How can I find it?
Just replacing the A over sine of A to B over sine of B.
Okay, so the only catch there is I'm missing both side B and angle B, right?
Yeah.
So how?
We find angle B first by just doing 43 plus 20 and then minus 180.
Exactly. So 180 minus 43 minus 20, or 180 minus 63, is 117. So now I've got angle B. Now I can set up the ratio using C over sine of C, so 32 over sine of 43 equals side B is my unknown over the sine of 117. Now we found side A, right? So could I have also done this instead of using the C's, using the A's? Yeah. What's the benefit to sticking with the C's?
It's not rounded.
Good. It's not rounded and we know it's right. If you screw up A and then you use A, you're screwing up B too. So you always want to stick with the information that was initially given to you. 1, it is 100% accurate. 2, it's not rounded. All right, so again, we're going to cross multiply 32 times the sine of 117 equals B times the sine of 43, and then divide both sides by the sine of 43. These cancel, and I get 32 sine of 117, closing the parentheses, divided by the sine of 43, and I get side B is 41.806, so 41.81. Again, the quiz and most of what you're going to do will tell you to keep both decimal points, or 2 decimal points, on these types of questions. So you want to be consistent. Sometimes it'll say nearest tenth. You'll see it like when we get to word problems and stuff, but most of the time it will say 2 decimal places. Questions on that one? So the type of information you were given on this, if it was written out, is an angle and a side that's not included. So it's angle, angle, side. If you're given that kind of information, you'll always use law of sines. You can't use law of cosines. All right, you do it. You try it. Set it up and solve it. Alright, this is what you should have gotten. So angle B you found by subtracting from 180 both the 79 and the 35, it's 66. And then side A 12.27 and B 19.54. Everybody good? How many of you got it right? Good. Okay, so while you're starting to prepare yourself for not standardized tests, but tests and quizzes on Canvas, this would be a multiple fill in the blank in which you'll get the parts that are missing and you'll literally type in those answers, okay? It's going to be picky about rounding, so you have to be really careful. If you're off, it's going to mark it wrong. And you just want to be careful and you make sure you're filling in the right ones at the right spots. I will be checking this time your setups. So on your answer sheet, okay, I'm going to go back in and make sure that you're giving me at least this part. So while you can obviously do most of the work on your calculator, I want to make sure that at least you show that stuff, and you want to be practicing to show at least that stuff, because if you get it completely wrong, I don't want to dock you all the points, obviously. And if I have if I have nothing to look at, like what you did in your calculator, I can't go back and see that, and you don't have this, then there will be no partial credit. So you want to make sure you're really careful and you make sure that you're showing at least that step. You can do the cross multiply, obviously too, but at least that step needs to be on your scrap work. Okay, so here is where law of signs goes from like this super easy formula, cross multiplying, divide, things you've been doing for a long time, to a pain in the butt, and that is with an ambiguous case. So an ambiguous case means that there's like this hinge theory. If I had two angles and I had one side, but it was the non-included angle, I can actually take that third side and swing it in or swing it out and make a triangle, which means two completely different triangles are formed, okay? They are both correct. They are both options that are correct, which means you have to account for them. So the way that this is like one way to figure it out is you find the H and then you look at the H in respect to the A and the B and you figure out if there is an ambiguous case. There's one way to do it. So you can find the H, like I said, you find the H by doing B sine of A. Now it's not always going to be those same letters, but it would be that. And then if A is greater than H and greater than B, one triangle is formed. If A is equal to H, then there's only one triangle, it's a right triangle. If A is less than H, but it's not long enough to form the triangle, then there's no triangle possible. If A is greater than H and less than B, then two triangles are formed. For me, I'm going to teach you the way that I approach it, which is assume that there's a second triangle until you can't find it. So I would recommend doing that over this, but just know this is an option. You can find H and then find the relationship between A, H, and B, okay? Or you can do what I'm about to teach you. I just want you to know that those are both options. Years, and I think that the way we're doing it is the easiest way to do it. So this is what we're going to go through. We're going to say if I'm given two sides in a non-included angle, so if the letters that they give you spell a bad word forwards or backwards, okay, then, which means ASS or SSA, if that's what they give you, then you're going to assume there's a second triangle until you prove yourself wrong. And the way you'll find it is you'll use law of signs to find the first missing angle. We're going to call that whatever letter it is. So if it's B, we're going to call it B1. And then we're going to assume that there's a B2, and you find B2 by subtracting B1 from 180. There's supplements, okay? Then you split and you solve two completely separate triangles, okay? The first one will either work all the way through or it won't work, and that means no triangle can be formed. That's one case. That's the lucky case. It will work all the way through, and then you'll go to find the second triangle, and that one will have a negative third angle, and that means that there's only one triangle. Or both triangles will work all the way through, and you'll know that there's two triangles, okay? Again, I'll kind of walk you through as we go through this, but just know that those, I feel like sometimes people need the words. Those are the words, okay, if you get back. All right, so we're going to look at this triangle. First of all, we want to identify what we're given because we don't need to test for an ambiguous case every time, only if what we're given is side-side angle. So look at my triangle. I'm given two sides, 1, 2, and the non-included angle. Which angle would be the included angle for side A and side C? What's included mean?
This red.
Huh?
The 81.
Good. Well, no, not the 81. That wouldn't be included. For A and C, it's where A and C meet. So where does A and C meet?
Also, the include angle would be
Yep. So if they gave me B, it's fine. There's no possible second triangle. It's the non-included angle, right? If they give you A and then angle B and C, you're actually going to use law of cosines, which you'll see on Wednesday. But if they give me two sides, right? That's definitely two sides. We see that's two sides, yes. And the non-included angle, which is either A or C. If they give you those, then you have to test for an ambiguous case. So the first thing I'm going to do is I have one complete ratio, right? I have A. So I'm going to say A over the sine of A equals the other piece of information I have is side C. C over the sine of C. Now because this is ambiguous, I'm going to call this C1. The thing I'm finding. Because I'm going to assume that there's two of them. So I plug in A. A is 20. The sine of angle A is 81. Side C is 12. And the sine of C1 is what we're going to find. Cross multiply here, 12 times the sine of 81 equals 20 times the sine of angle C1. Divide both sides by 20 and type this into the calculator. 12 sine 81 divided by 20. And I get the sine of C1 equals 0.5926 and so on and so forth. Now this is not like finding the side. That's not my answer yet, right? The other side of that doesn't say angle C. It says the sine of angle C. So if I'm giving you the sine and I want the angle, what do we have to do? Instead of times it. Good. Wait, go ahead.
Sine -1.
Good. So I'm going to do sine -1 of that. And I'm not going to round it. Which means on your graphing calculator, actually this is why I wanted to do it. I can do second sine -1, so it looks like that. And then I can go second answer, and it's going to pull back in the answer I just had, and then hit enter. And I get angle C1 equals 36.34 degrees. Okay, so with me so far, that was just finding that first angle, right? So what's different now is instead of assuming that there's only one triangle and that's all we've got, we're assuming that there's a second triangle. So to remind myself, I immediately come over to the side and I write second triangle. And the first thing I find of that second triangle is angle C2. So the first thing you find on the first triangle is the first thing you find on the second triangle. And the way we find it is doing 180 minus what we just found, 36.34. All right, so we're assuming there's a second triangle and that angle C1 is 143.66. Again, you find that second angle by doing 180 minus the first one you found. Then I'm going to continue with the left triangle. So I'm going to assume everything we already know is true. We already have A, we already have angle A, we already have side C. Now we have angle C. The last things we have to find are angle B1, which I can find by subtracting 180 minus A, the 81, minus C1, which is 36.34. So finding the third angle of the triangle just by subtracting the other two from 180. Now I've got C1, I've got angle B1, and the last thing I need to find is side B1. So I'm going to still use my full complete ratio from A, which is 20 over the sine of 81, equals, now there's a little b, or side B1, sine 62.66. And then I cross multiply, so 20 times the sine of 62.66 equals B1 times the sine of 81. Divide both sides by the sine of 81. And I get 20 times the sine of 62.66 divided by the sine of 81. And side B1 is 17.987 So 0.99. So that was completing triangle 1. So I'm actually going to come up to the top and I'm going to write angle B. C1 was the first one we found. 36.34 degrees. Angle B1, which is 62.66 degrees. And side B1, which is 17.99. With me so far? So that process didn't change. What did change is now I have to work on a second triangle. So I took, again, the first angle I found, I subtracted it from 180 to find this completely second triangle. And that's using angle C2 as 143.66. Now I've got to find angle B2. So I'm going to do 180, because it's a triangle, minus A is still part of both triangles. So minus 81 minus 143.66. What's going to happen if I take 180 and subtract 81 and then subtract 143.66 from it? Yep.
So wait, what was the purpose of doing the second, like, going to the second triangle and then going to B1?
I didn't use
Like,
B1.
what was the purpose to find 143?
That is your second triangle angle. Your possible second triangle angle. So with all of these, you're going to get one angle given to you at the beginning. Because that's what creates an ambiguous case, one angle. Then you're going to find the second angle, right, of that first triangle like you normally do. But you have to assume there's a second triangle. And the second option, that second triangle, is the supplement to the first angle you found. Not the one that was given. The one that's given is true for both. But the first angle that you find, the option for one triangle is that angle. Then the second triangle is the supplement to the one you find, which is that 143.66. Now what happens if I do 180 minus 81 minus 143? What kind of number is that?
Negative.
Is negative. Can I have a negative angle? No. So this is when I say there is no second triangle, and that first triangle is the only one that works. So if when you go to find your second angle on the second triangle, it is positive, that means there's a second triangle. Negative means there's no second triangle. In my opinion, this one step is way faster than finding H and then comparing it to A and B. But again, that is your other option. We're going to do a couple examples of these. But this is the first option, is that you find a first triangle, you go to find the second one, and that third angle is negative. That means there's only one triangle. Same type of information given here. An angle and the two sides in which that angle is not included. So this is a non-included angle. This is a side-side angle, which means ambiguous case. So I'm going to start exactly the same way. I have full A's. So I'm going to do 12 over the sine of 69 equals, now I have B. B, which is 15, over the sine of B1. So we're going to call it B1 because we're going to assume there's a second triangle. Cross multiply 12 times the sine of B1 equals 15 times the sine of 69. Divide both sides by 12. 15 sine 69 degrees divided by 12. And I get angle B1 equals, or the sine, sorry, of angle B1 is 1.1669, so on and so forth. And then I want to do what with that number?
Inverse.
Good. So sine -1 of 1.166. And what's going to happen in your calculator? It's yelling at you, right? It's like, hey, you can't do that. Can the sine of an angle be bigger than 1? No. So this means no triangle. Those are the ones like when you get that quiz, you're like, yeah, thank you, Miss Chris Weiser. Guess what? Some of you are going to get, some of you aren't. Yeah. So there are three options, right? We did one where there was one triangle. This is no triangle. The third is the one you hate me for, but it's going to happen. So, and that is that there's two triangles, okay? So we start exactly the same way. It's angle, angle, side. So I start with 12.3 over the sine of 62 degrees equals B, which is 13, over the sine of B1. Cross multiply, 13 times the sine of 62 equals 12.3 times the sine of B1. Divide both sides by 12.3. 13 sine 62 divided by 12.3, and I get 0.933 equals sine of B1. I'm going to second sign it by pulling back the answer. So second sign, second answer. And I get angle B1 equals 68.934, no, 38, sorry. So 0.94. There's angle B1. So I'm going to say, okay, I think there's going to be a second triangle this time. Spoiler alert, there's going to be a second triangle this time. And that would be angle B2 is 180 minus angle B1. 180 minus 68.94. Which is 111.06. So if this angle plus the angle I'm already given is not bigger than 180, there's going to be a second triangle. If it is bigger than 180, then obviously there's not. That's where the negative would come from. So I'm going to continue to find the one on the left. My first triangle, I have A, I have side A, I have B, I have side B. I'm missing angle C1. So I do 180 minus the A that was originally given, minus the 68.94. And I get 49.06. And then I use my ratio of A's again. So 12.3 over the sine of 62 equals C1 is what I'm missing, the sine of 49.06. Cross multiply. And divide. So 12.3 times the sine of 49.06 divided by the sine of 62. And I get C1 equals 10.52. So my first triangle has all the information I already had, plus angle B1 equals 68.94. Angle C1 is 49.06. And side C1, 10.52. Now I got to finish out that second triangle. So I have A, B2, I need C2, which is 180, minus A is still part of both, so 62 still goes to both. 180 minus 62 minus 111.06, which is 6.94. Now that's small, but it is positive, which means there is a second triangle this time. B2, 111.06. C2, 6.94. And the last thing I have to find is side C2. So I still use the original information they give me. My A is still part of both triangles. So 12.3 over the sine of 62 equals C2, lowercase c because that's a side, sine 6.94, cross multiply, and divide. So 12.3 sine 6.94 divided by sine 62. So remember, if you are given two sides in the non-included angle, there's three options. One triangle, which happens if that second triangle's last angle would be negative. No triangle, and you get an error right away on your first one. Or two triangles, which is like this, where you've got to find two completely different sets of information. So the homework, it's not due till Wednesday because we're going to work on this a little bit more tomorrow, and I'm going to add in, word problems and area. But you can start it. It's going to feel like a lot if you save it for tomorrow because there's parts that are on WebAssign and then parts that are also on your PDF. So you can get through the parts that are on your WebAssign of the solve the triangle and the first question on your PDF, which is solve the triangle. That's two triangles, okay? So you can get that started and then save the area and the word problems for tomorrow. Bye, guys. Have a fantastic day.